Hello, everyone. Welcome to this live tutoring session from Namaste Online Tutoring. So today we are going to work on the area of composite figure. I'm going to explain you a couple of examples. We are not going to work on the theoretical part. We are just looking at a couple of examples on how we can find the area of composite figure. If you want to watch videos like this in future, don't forget to subscribe to this YouTube channel given here. Okay, let's get started with the first example. So we are really looking at very simple problems today, but the area of composite figure. So here we are asked to determine the area of the composite figure given below. So you can see we have a pair of parallel sides, and then we are asked to find the area of this quadrilateral. You can find the area of this quadrilateral in several different ways. One of the easiest way is you can draw a line here like that, so that this one, the figure here is a rectangle. This is a rectangle. Okay, that's a rectangle. And figure at the down over here is a triangle. And you can find the area of each of these and add them together. So for example, here, if we want to find the area of this rectangle, let's call it area 1. It is equal to the base times height. Okay, base times height. So that will be equal to, here we have 4 as the base, or this is 4. And then we multiply by the height, and height over here is a 9. So we get 9 times 4 equal to 36 square units is the area of the rectangle over here. Whereas area of this triangle down here, let's call it A2, is base times height divided by 2. And over here, as you can see, the base of this triangle is this one, the line that I have drawn, which is equal to this, that's a 4. Times the height. Height of this triangle is this little height down here. The total distance from top all the way up to the bottom is 10, but this much height here is 9. That means this remaining height over here is 1. So 4 times 1 divided by 2, which is equal to 4 over 2, or 2. So we can write A2, the area of the triangle, is equal to 2. That means the total area will be, so total area is this area of the rectangle plus area of the triangle. Area of rectangle is 36 plus the area of triangle is 2. That is equal to 38 square units. Okay, 38 square units. So this is how we can find the area of the shape like this. But this shape is pretty unique in nature, because if we look at this shape in little detail, let me show you here. You can see these two angles are 90 degrees, meaning of that is this side and this side are parallel. So a pair of sides are parallel, pair of opposite sides are parallel in this quadrilateral. Meaning of that is this whole shape, okay, the single shape, this one, the whole shape is a trapezoid. So we can find the area of trapezoid directly. So we know that the area of the trapezoid A is equal to base multiplied to height 1 plus height 2 divided by 2. So that's the formula. So base here is a 4. Okay, base here is a 4 multiplied to height 1 plus height 2. This side we have the height of 9. And on the other side we have the height of 10. Divide that by 2. So that will be equal to, over here, 4 divided by 2 is a 2. And then times, inside the parenthesis, we have 9 plus 10, which is 19. So 19 times 2 equal to 38. So that is 38 square units. Okay, so in this first method, what I did is, in method 1, I used the concept of composite figure, because our whole figure, the single structure that's given here, composed of two different things, the rectangle and the triangle. So I use the composite structure. Composite structures here. Okay, or I use the composite shapes to find the area. Over here, I use the entire figure as a trapezoid, and found the answer. So it really depends on how you are going to perceive this figure. When you look at the diagram, what it look like to you, okay? And based on that, you can find the area. You can use the composite shapes. If you know the area of the entire shape, you can use that formula. So either way, you should be able to get the same result as I get here. In both case or by both methods, we get 38. Remember one thing, in math, there are several different ways of solving a problem we call multiple pathways. So you should be able to approach a problem using multiple ways. The best thing or the basic idea is you have to understand the fundamental concept of it. So once you know the fundamental concept, you have several different approaches to solve the problem. Okay, this is the first example. We are working on 4 problems. So let's move on to second problem here. So here is the second problem. Again, we are asked to determine the area of the composite figure. So my goal today will be more about, creating different shapes out of a given shape and then finding the area. So over here, you can see that this quadrilateral is given. What I'm going to do is, if I construct a line, let's say, if I construct a line here, just like that, you can see that here is one triangle, okay? Here we have one triangle. See, I'm shading here in blue. That's one triangle. And down here, there's another triangle. Let me say that in red. So that is the other triangle in red. So you can see there are 2 triangles there. But one important thing for you to note here is, in the problem, they have clearly given that here is 90 degree, up here, this is 90 degree, okay? And also here, they have given that this is 90 degree. So if these 2 angles are 90 degree, meaning of that is the sum of these 2 angles is 180 degree. If the sum of interior angles is 180 degree, then we know that this line up here and this line down here, they are parallel. And if the lines are parallel, distance between the parallel line is always the same. And the meaning of that would be, if we want to know the height of this triangle here, you can clearly see it is 5. Similar, the height of this triangle, the one which is shown here in blue, okay, that height will also be 5. This height will also be 5, okay? So we can find the area of these 2 triangles, area of the triangle, which I shaded here in blue, plus the area of triangle, which I have shaded here in red. So first of all, let's find the area of this triangle here. So area of triangle 1, okay, let's call it A1, is equal to, area of triangle is base times height divided by 2. And base here is 6. This is the base, which is 6, times the height. We already discussed the height will be 5, the same number which is here, 5 divided by 2. And you can see here, 6 divided by 2 is 3, times 5 is a 15. Okay, so area of this triangle is 15. Similarly, if you want to find the area of this triangle down here, that would be, okay, area of triangle 2, which is also labeled as A2, is same formula, base times height divided by 2, which is equal to, base in this case is 8. 8, and the height is 5 divided by 2. So you can see here, 8 divided by 2 is a 4, times 5 is a 20. So the total area is equal to 15 plus 25, 20, 15 plus 20. That is equal to 35 square units. Okay, 35 square units. So you can do it like this, or there is also a second method that I want to show you here. Let me call it alternative method. Alternative method. What you see here is, as we discussed already, you can see that these two lines are parallel. A pair of opposite sides are parallel, and we have given the height. That means once we know that the pair of opposite sides are parallel, this figure, this quadrilateral, is a trapezoid. And we can find the area of this trapezoid directly by using the formula. So we can write this as area of trapezoid. Trapezoid A is equal to base multiplied to height 1 plus height 2, or sum of parallel sides, you can also say that, over 2, which is equal to, let me write here, base for this one, you have to know the base, okay? And then, so you can see this one can be considered as a base, okay? This one can be considered as a base 5, okay? And then we have height 1 plus height 2. This can be considered as the height. That's one way of thinking. But if you want to think a little differently, we can also do this. Instead of writing this formula like this, we may also write formula a little differently. Let me write a different formula in a different form here. So we write distance, d, the distance between the parallel sides, multiplied to, okay, multiplied to a plus b, that's those parallel sides, divided by 2. Same formula, but written a little differently. D is the distance between the parallel side in this case, which is a 5. Okay, multiplied to sum of the parallel sides, 6 plus 8. 6 plus 8. And then we have to divide it by 2. So what we get is 5 times 6 plus 8 is a 14 divided by 2. And you can see here, 14 divided by 2 is a 7, times 5 is a 35. 35 square units. So we can do it in any method again, okay? But you must understand the fundamental concept, and then you should be able to solve it in any method you want. So here, we found this area of the quadrilateral using two different methods. In first method, we break the figure into two parts, and then we calculate the area of each triangle. Here we break into two triangles, and we calculate the area of two triangles, add them together to get the result. Whereas in the second method, what we did is, we look at this figure as a trapezoid, and we directly use the formula to get the area. So either way, it works. Okay, let's move on to next one. Okay, here is the third figure. We are asked to determine the area of the composite figure given below. And here they have clearly shown three different structures. Here on the top, there is a triangle. Let me show you. This is a triangle. They have given a triangle. Here in the middle, this is a rectangle. And down here is the triangle. So the easiest approach here would be find the area of this triangle, this rectangle, this triangle, and add them together. So for this one, area would be, for this triangle, area would be base times height divided by 2. And over here, for this triangle, base is this distance here. This one is the base, which is equal to this one, that's 8. So base is 8. Times height. Height is how tall is the triangle. So you can see here, this triangle is 2 units tall. So times 2 divided by 2. That is equal to 8, because 2 over 2, 2 and 2 cancel. So you got 8 there. So that is the area of the triangle, which is here on the top. Now let's find the area of this rectangle here. And you know that the area of rectangle is base multiplied to height. Base over here is 8. And the height is, this is the height, as you can see here. This is the height. Height is 7. 7 times 8 is 56. Okay? And finally, we have to find this one. This is a triangle here. And you know that the area of triangle is base times height divided by 2. And for this triangle, base is this one again, 8. And height is how tall is this triangle, right? How tall is this triangle? And you can see that this is 3 units. So the height is 3 divided by 2, which will be equal to 8 divided by 2 is a 4 times 3 is a 12. 12. So we can find the total area. So total area would be equal to 8 plus 56 plus 12. So here, all we need to do is add these 3 numbers and find the value of the area. So we are adding 8 plus 56 plus 12. So if we add that, that will be 76. 76 square units is the area of this composite figure given here. I found that it's quite easy when you look at these 3 steps, and then I use that method, okay? Calculated the area of the triangle on the top, calculated the area of rectangle in the middle, and calculated the area of the triangle at the bottom, add them together to get the total area. Okay, let's look at one more example from the area of composite figure. So this one looks a little different. So here, what we have to do is we have to find the area of this shaded region here. Okay, we have to find the area of shaded region here, and they have given this external height down here, from here to the bottom and from here to the bottom. So in this one, you can see that there is a external structure here. If I show you here in red, as you can see, if you look at this external structure here, this external structure is a rectangle, right? That's a rectangle because this side we have a 9, and this side we have 5 plus 4, 9. Oh, in fact, this is a square, right? 5, and then 4 is a 9. This side also we have 9. So that's a square. So we can find the area of this outer square. But what is going on here is from this square, they have removed the area. They have removed the little area. Let me show you here in green. They have removed this area in green. That is, they have removed the area of this triangle. And also they have removed the area of this triangle. Okay, from this big square, they are removing the area of these 2 triangles so that we can get the area of this shaded region. So first of all, the area of this square in red will be, area is equal to, okay, area of this square, it's base times height again, but base and height are equal. You can still write base times height, which is 9 times 9 equal to 81. So area of this big square, which is outside, is 81. Now we have to remove the area of this triangle and this triangle. So let's do that. Let's find the area of this triangle here. Let me show you here. So area of this triangle, that is equal to base times height divided by 2, which is equal to, you can see base is a 4 and height is a 5. So it will be 4 times 5 divided by 2. 4 times 5 is a 20, divided by 2 is 10. So this area that is removed is 10. Similarly, here also, the area of this triangle is removed. Let's find that area also. So that area of that triangle, for that triangle, the area is again base times height divided by 2. If we plug in the values, base is 3, height is 4. So it will be 3 times 4, 12, divided by 2 is a 6. So technically what we are doing is, in order to find the area of this shaded region here, we have to subtract 6 and 10 from 81. So let's write that down. So area of the shaded region, okay, area of the shaded region, I can write this is equal to 81 minus 10 minus 6. Okay, from 81, we are subtracting these 2. That's the meaning of that. You can also write this as 81 minus 16. you are subtracting a total of 16. 10 and 6 you are subtracting, that is, you are subtracting 16. So 81 minus 16 is 65. That is equal to 65 square units. So 65 square units is the area of this shaded region which is given here. Okay, so that's all about today's session. You can see we learn how to find the area of composite figure. One more time, it really depends on you how you are going to see the figure. Okay, but make sure you use the concept properly and wisely so that you'll be able to get the answers. If you have any questions, you can reach out to me. But for today, we are ending our live session here. Thank you so much for participating. And as always, if you need to, watch videos like this in future, don't forget to subscribe to this YouTube channel. Okay? Thank you and have a wonderful time.